Welcome to another interesting lesson in basic calculus. This is your teacher, Jennifer Basilia de Leon. All aboard! In the previous lesson, we have learned the definition of the derivative of the function, and we have also experienced how to find the derivative of a function using the delta method. So today, let's have a short recall of what we have learned in the previous lesson. Find the derivative of f of x equals x plus 1. Now, applying what we have learned, we will have f prime of x is equal to x plus delta x plus 1 minus x plus 1 all over delta x. Now, we simplify further. We will have x plus delta x plus 1. Distribute this negative sign. So we will have negative x minus 1 all over delta x. Now we simplify the numerator by combining similar terms. So we can cancel x minus x, that's equal to 0. Then 1 minus 1 is also 0. So we only have delta x in the numerator and delta x in the denominator. Now delta x divided by delta x, we will have 1. So therefore, the derivative of f of x equals x plus 1 is 1. I hope you were able to recall what we have discussed in the previous lesson. Now today, we shall discuss the different differentiation rules to help us in finding the derivative of the function without undergoing a very tedious process such as what we have experienced in using the delta method in finding the derivative of a function. So we have the following rules. Now to help you master these rules, let's work on with specific examples. Let's have example number 1. Find the derivative of f of x equals 6. Now, since we have a constant function, we shall use rule number 1. If f of x is equal to c, then f prime of x is equal to 0. So therefore, f of x equals 6. The derivative of f of x equals 6 is 0. Now let's work on example number 2. Find the derivative of f of x equals x. So this is an identity function. Now the derivative of an identity function is equal to 1. Okay. Probably you are wondering why it happened or why we got 1. Okay. So as you can see in the exponent, we have 1, and in the numerical coefficient, we also have 1. Now, to get the derivative of a function, especially an algebraic function, we will have to do the following. Multiply the exponent by the numerical coefficient, so 1 times 1 is 1. Now, all we have to do is to deduct 1 degree in the term. So we shall have 1 minus 1. So simplifying this, we will have 1 times x raised to 0. Now remember that whenever we have a non-zero number raised to 0, the answer for the simplest form is 1. Okay, so 1 times 1 is simply 1. Okay, so remember that the derivative of a constant function, the derivative of an identity function is 1. Now let's work on example number 3. Doing the same thing, we have to determine the exponent and the numerical coefficient. In f of x equals x cubed, the numerical coefficient is 1, while the exponent of x is 3. So all you have to do is to multiply the exponent by the numerical coefficient, so we will have 3. And then we deduct 1 from the exponent in order to reduce the degree by 1. So simplifying, the derivative of f of x equal to x cubed is 3x squared. Now let's have example number 4. Doing the same as what we have done in the previous example, all you have to do is to multiply the exponent by the numerical coefficient. So this time the numerical coefficient is 2 and the exponent is 3. 3 times 2, that is 6. Then we deduct by 1 degree. So we will have f prime of x is equal to 6x squared. Now, what if we have f of x equals 2x cubed minus 3x squared plus 5? Now, all you have to do is to take a look at the rules. Here, we shall use these rules. Okay, since we have a subtraction operation and then an addition operation. Now, applying what we have learned in the previous example, all you have to do is to multiply the exponent by the numerical coefficient. So we will have 6. Then we deduct by 1 degree. So we will have 3 minus 1. Repeating the same process, we will have 2 times 3, that is 6. And then x will have an exponent of 2 minus 1. Now remember that whenever we have a constant, the derivative is 0. Simplifying further, we shall have f prime of x is equal to 6x squared minus 6x. Now let's have example number 6. This time we have a product. Now looking at rule number 5, if f of x is equal to uv, then f prime of x is equal to uv prime plus vu prime. Now take note, u and v are functions. So let's say we have u equals to 2x minus 1, and then v equals to 3x squared plus 2. Now to get the derivative of u and v, all we have to do is to multiply the exponent by the numerical coefficient. So 1 times 2, that is 2. And we deduct by 1 degree. So since this is on the first degree, then we will have 0 degree. Okay, 0 degree. Now any number raised to any non-zero number raised to 0 is equal to 1. So simply u prime is equal to 2. Now for v prime, we will have 2 times 3. So we will have 6. Then deduct by 1 degree. So, and then the constant, we will have 0. So v prime is equal to 6x. Now, following the format, okay, it says that the derivative of a product is equal to uv prime. Okay, so u is 2x minus 1, and then v prime is 6x. Then we have plus vu prime. So our v is 3x squared plus 2, and our u prime is 2. And then we just simplify by applying distributive property of multiplication. We will have 12x minus 6x, and then here in the second term we will have 6x By the way, applying distributive property, we will have 12x squared, then minus 6x. In the second term, we will have plus 6x squared, and then plus 4. So, simplifying, we will have 18x squared minus 6x plus 4. So, the derivative of the given function is 18x squared minus 6x plus 4. Now, let's verify, okay, what if we will apply FOIL method first and then we get the derivative. Okay, we will use FOIL method to get the product of these two binomials. So 2x times 3x squared, we will have, okay, we will have 6x cubed. Okay, 2 times 3 6, then we add the exponent. Then 2x times 2, that is 4x. And then negative 1 times 3x squared, that is negative 3x squared. And then negative 1 times 2, that is negative 2. So let's arrange the terms in decreasing powers of x. So we will have 6x cubed minus 3x squared plus 4x minus 2. Now simplifying, we will have f of x is equal to 6x cubed minus 3x squared. We are arranging the terms in decreasing powers of x. So we will have 4x minus 2. Now getting the derivative of this polynomial by applying addition and subtraction rule, we will have f prime of x equal to 3 times 6, that is 18, then deduct by 1 degree, we have 18x squared. Then here, 2 times 3 is 6, then deduct by 1 degree, we have 6x, and the derivative of 4x is 4. Now take a look at our answer. Is it the same with what we have found a while ago? Definitely it's the same. Okay, now if you only have two binomials, you can use FOIL method to get the product and then apply the addition and subtraction rule for finding the derivative of the function. Okay, however, when you have a trinomial or a polynomial with more than 3 terms, that would be difficult or tedious. Okay, instead we have to use the product rule in order to have a shorter way of finding the derivative of a function. Now let's work on with example number 7. This time we have a quotient. So let's take a look at rule number 6. If f of x is equal to u, v, then f prime of x is equal to vu prime minus uv prime all over v squared. So let's start defining u and v. So u is the numerator, 2x squared, and v as the denominator, or the denominator as v. Then we will have u prime is equal to 4x, and then v prime is equal to 3. Now applying the rule, we will have, okay, vu prime. So that means we have to multiply 3x minus 1 times 4x minus u, that is 2x squared, then v prime, that is 3, all over 3x minus 1 raised to the second power. Now apply distributive property, so we will have 12x squared minus 4x minus 6x squared all over the square of 3x minus 1 raised to the second power. Okay, we combine similar terms. Then we will have 6x squared minus 4x all over the square of 3x minus 1. Now let's take a look if we can cancel out something. By expressing the numerator in factored form, we extract the greatest common factor, which is 2x. Okay, so we will have 6x squared divided by 2x, that would be 3x. Now, negative 4x divided by 2x, that is 2. So let's see if we will have a common factor in the numerator and in the denominator. Okay, so unfortunately we cannot cancel 3x minus 1 and 3x minus 2 because they are different. So therefore, the derivative of the given function is the quotient of 2x times 3x minus 2 and the square of 3x minus 1. Now let's work on with example number 8. Find the derivative of f of x equals the square of 5x minus 2. Now since we have a square of a binomial, we can apply what we have learned in grade 8 about special products. So we can expand, okay, f of x will be equal to square the first term, that is 25x squared, square the last term, then we have 4. Now to get the middle term, we multiply negative 2 times 5x, that is negative 2 and negative 2, that is negative 10x times 2, so we will have minus 20x. So we get the derivative using the sum and the difference, okay, and some other rules. So we will have 50x minus 20. Now applying this rule specifically, rule number 2, okay, we have our u, which is 5x minus 2, and then we have here, okay, simply we will have 2 times the numerical coefficient here is 1, so 2 times 1 is 2, and then we subtract by 1 degree, so 5x minus 2 is just so 5x minus 2 will then be reduced to lowest term, or we have to reduce by 1 degree, so this will be 1, and then we get the derivative of the binomial, so we will have 5. Therefore f prime of x is equal to, okay, let's distribute now. We will have 2 times 5, 10, okay, and then simplify further to check if we have arrived at the same answer. So we will have 50x minus 20. So it's the same as this. Now let's have example number 9. Find the derivative of f of x equals sine 3x. Okay, we use rule number 7. So f prime of x is equal to cosine x. So our x is this whole expression. So we will have cosine 3x, and then the derivative of 3x, that is 3. So therefore, the derivative of f of x equals sine 3x is equal to cosine 3x. Now we have to write the multiplier 3 in front to avoid confusion. So here we have f prime of x is equal to 3 times cosine 3x. Now let's work on example number 10. Find the derivative of f of x equals to cosine x squared. Now as you can see in rule number 8, if f of x is equal to cosine x, then f prime of x is equal to negative sine x dx. So here we will have f prime of x is equal to negative sine x squared, and the derivative of x is times 2x. So simplifying, we will have negative 2x sine x squared. Now let's have example number 11. Find the derivative of f of x equal to tangent 6x. So we use rule number 9. Therefore, the derivative would be in this form. So f prime of x is equal to secant squared x. So we will have 6x, and the derivative of x is 6. So f prime of x is equal to 6 times secant squared 6x. Okay, that's the derivative whenever we have a tangent function. Now let's work on example number 12, wherein we have cosecant. So this time we follow this rule number 10. So f prime of x would be equal to negative cosecant 4x squared minus 1 times cotangent 4x squared minus 1 times dx. So the derivative of x is 8x. Okay, so simplifying, we will have negative 8x cosecant 4x squared minus 1 times cotangent 4x squared minus 1. Okay, let's proceed to example number 13. This time we have the secant function, and then we have negative 2 here. So for your hints, we will use the product rule since there are two factors here, negative 2 and secant 5x. So let's have u equal to negative 2 and then v equal to secant 5x. And then u prime is 0 while v prime is equal to, looking at the derivative of a secant function, we will have this form. So we have secant 5x, then tangent x and tangent 5x, and then dx is 5. So simplifying v prime, we will have 5 secant 5x times tangent 5x. So we now get the derivative of the function using the product rule. So uv prime plus vu prime. So we will have uv prime, so negative 2 times 5 secant 5x tangent 5x, okay, plus v u prime. So we have 0. Simplifying this, we will have negative 10 secant 5x tangent 5x plus 0. So simply we will have f prime of x is equal to negative 10 secant 5x tangent 5x. Now let's work on example number 14, wherein we have cotangent function. So cotangent, that is rule number 12. Therefore, f prime of x is equal to negative cosecant squared, and our x is 13x, and the derivative of 13x is 13. So simplifying, we will have negative 13 cosecant squared 13x. Okay. Now what about if we have an exponential function? So take a look at this. We have, if f of x is equal to e raised to x, then f prime of x is equal to e raised to x dx. So therefore, we will have f prime of x is equal to e raised to 5x plus 2. Then the derivative of dx, okay, is 5. Simplifying this, then the function would be 5e raised to 5x plus 2. Okay, I hope you get that. Now let's have number 16, our last example for finding the derivative of a given function using differentiation rules. Now, since we have an exponential function, then we shall use rule number 14. If f of x is equal to a raised to x, then f prime of x is equal to a raised to x ln a dx. So here, we shall have f prime of x equals a raised to x, meaning we will just have to copy, okay, 8x plus 2, and then we shall have ln a, okay, times ln 8, then the derivative of x plus 2 is 1. Okay, so simplifying, we shall have 8 raised to x plus 2 ln 8. Now let's apply what we have learned using or through this problem. Find the equation of the tangent line and the normal line to the graph of the function defined by f of x equals x squared minus 3x at 2, negative 2. So if you can still recall, our first step is 2. Okay. Find the derivative of f of x. So f prime of x would be 2x minus 3. And then we evaluate step 2. Okay, step 1, step 2. We shall have to evaluate f prime of x at 2. Where did we get 2? This is the abscissa, which is equivalent to the x value of the ordered pair. So we will have 2 times 2 minus 3. Okay, so therefore we will have 1. So since the derivative is equal to 1, okay, that means the slope of the tangent line is also equal to 1. So to write the equation of the tangent line, we shall use the point slope form of a linear equation. Okay, in this particular case, m is equal to 1, and then the value of x and y is also given here. So let's replace y minus. Since it's a negative 2, later on you will have a plus sign. And the slope of 1 times x, that is just x, times x sub 1, ay mali. Now substituting the known values to this equation, we will have y minus, since we have negative 2 as the coordinates, we will have y minus negative 2. Then the slope is 1. Okay, multiply that to x. So that is x, and then substituting the known values, we shall have y minus negative 2, and then the slope is 1, and then the x value is 2. So simplifying, we will have y plus 2 is equal to x minus 2. Now let's write the equation in this slope-intercept form. So transpose positive 2, you shall have y is equal to x minus 2 minus 2. So we shall have a negative sign here. Okay, now we simplify further. So we shall have y equals x minus 4. Therefore, the equation of the tangent line is y equals x minus 4. Now looking at the second problem where we are asked to find the normal line. Now remember that the slope of the normal line is the negative reciprocal, okay, of the slope of the tangent line. So if the slope of the tangent line is 1, therefore the slope of the normal line is negative 1. Okay, so let's see, using the point slope form, we shall have y minus negative 2 equals to negative 1 times x minus 2. Okay, so y plus 2, and then distribute negative 1 to each factor. We will have negative x plus 2. Simplifying this, then we will have y equals negative x. I hope you were able to master the differentiation rules so that we would be able a much easier way of finding the derivative of a function. So for now, I'd like to say thank you for being with me in today's lesson.